Hey guys, I'm Arnab, and today I wanted to talk about statistics in BI, right? And to be more precise, your descriptive statistics in BI. So, first of all, what is statistics exactly? Statistics is basically the art of making decisions under uncertainty. What is uncertainty? We'll come to that in a minute, but BI essentially is about using data to make smart decisions at an organizational level. That's what business intelligence stands for. So, these are the two concepts we are playing with. Now, if I just want to know what are the objectives of statistics in general, just scroll it down and see there are five main things. Firstly, we need descriptive statistics to report at a holistic level when we have all the data that we need, and if you want to do reporting on that, that's when we do descriptive statistics. So mean, median, mode, all these things come in here, right? And even standard deviations and all, we'll come to that. Then we model our data as per the probability distributions, right? Probability distribution is another concept. Then there's this concept of confidence intervals that are used to make inferences and estimations about the data. And we also draw conclusions by using hypothesis testing, which is the fourth step. And finally, we make predictions using regression analysis. So today I'll mainly be talking about the first one, right, which is descriptive statistics. That's today's agenda. Now, before getting there, why do we even need statistics, right? So, if business intelligence is about using data to make smart decisions, then statistics is about evaluating those decisions under uncertain conditions. So here we're looping back to where we started, which essentially is business intelligence being and like how business intelligence and statistics are connected, right? That's what, like, there's uncertainty that statistics helps us measure, whereas business intelligence is all about using data to make better decisions or choices, whichever we want to put it. So that's why we want to use statistics. Then there's this concept of population and samples. So if you population and samples are something that's where the uncertainty actually comes in, right? Like if we know a population essentially is the data that we are interested in, but more often than not we'll not have all the data, right? For instance, I want to know the average height of all citizens of India. Now, measuring all 1.4 billion people is a very tough task. So I'll take, let's say, 2 million people, measure their heights, and then draw an estimate. That's what samples are all about, like taking a subset of a data because gathering the whole data is a tedious task. So that's how you can summarize populations and samples, right? And if we talk about the workflow in statistics, so it goes like this. First, you use descriptive statistics to understand the data, like how it's distributed and all. Then you use probability distributions to model your data, which is to kind of understand the structure of it, right? Model it. Like if I want to know something uncertain, like if I have XYZ parameters about my data so that I can make a prediction about another parameter. I hope that makes sense, even if it does not sound very convincing. Just bear with me for now. Then there's confidence intervals, which is basically if a sample doesn't fit a distribution, then we use something called a central limit theorem to model it. All these will come to later in other videos, right? Today, I just want to talk about the first one, which is descriptive stats, right? And later on, we'll also get into an Excel project. That's the second half of the video to make the case for descriptive statistics. So let's just start here. Like, what's the purpose of descriptive statistics in general? It's to summarize the characteristics of a particular variable, right? Now, what is a variable? A variable is any quantity or a category. Let's say I just mentioned height of people in India. So height is our variable. So any attribute of a person or an entity is our variable in from a statistical perspective. Now, variables can be of two types, right? There are either numerical variables or there are categorical variables. Numerical variables are essentially numbers like 1, 2, 3, 4, decimals, 1.5, 2.5, these things. And categories are like, they can also, categorical variables are like text, right? They can be, let's say, small, medium, large. You get the idea, right? Like anything that's a text, essentially, that's a categorical variable. Hmm. Now let's just come to what are the different types of descriptive statistics. So yeah, first of all, we have distributions, right? So here we have frequency tables and histograms. We'll come to what this is in our Excel demo. I just want to introduce these concepts right now. They tell us how our basically the values of a of our variables are distributed, a particular structure. That's what we get to see here. Then we have central tendency, which is mean, median, mode, even skew to some extent. Coming to this in a while. Then variability is the spread of the data, which is in terms of the minimum, maximum, what is the range, interquartile range, and standard deviations. That's what this is all about. So yeah, now so we can start with the here. I can start with the definitions right away, but I would like to introduce the data first, right, about what we have. So what we're going to analyze right now is this data. So we have dates, we have the weekday, like what day is it on this day, and the number of pizzas that a particular company is selling. Okay, so let's zoom out a bit. We are analyzing the data for a company that sells pizzas, and we have the data for 2015, right? The whole year's data, and we want to see how it went, which days were more, profitable than the others, and we want to mix this analysis to see how things went for the past year. That's our agenda. Now, how will we be doing this? So I've completed this project right now. I just wanted to demo it to you guys today. So the easiest way to do these things is to first figure out the spread of the data to some extent. So if you look at this graph here, right, the histogram, this tells you the spread of sales essentially, like how many pizzas were sold and what were the frequencies. For example, straight off the bat, we can see that the highest number of pizzas, 89, were in the range of 125 to 137. This was the bin which had the maximum sales. What do I mean by binning? So this is the range which had the maximum sales, right? This is the category. Now, why do we need categories like that? Because it just makes more sense, right? The only way to have frequency distributions for a numeric variable which happens to be sales here is to bin them. So that's why. And out here, these are the bits 77 to 89 and accordingly, right? Now let me just go back to my this thing and introduce a few more concepts to you, which are regarding descriptive statistics. First is the purpose only. Like I think we've already covered the purpose of it. It's like to see how the data's distribution at holistic level. That's what descriptive statistics does for us, right? And yeah, just going by I'll just read it through once. So we're basically taking a lot of numbers and reducing it into a handful of numbers so that it's easier to interpret. That's one main agenda. And what else? Mm-hmm. So distributions again, yeah, I think we can skip this part and just start with the distributions only, right? What is the concept of distribution? They've introduced the basics already. Okay, so distributions can be of various types. There are categorical frequency distribution and this numerical frequency distribution. The categorical frequency distribution tells me how many number of times a particular category has occurred. For example, let's say I own a shop, right? And I'm a merchant who sells clothes, and there are three categories of a gray t-shirt, small, medium, large. How many times did small sell? How many times did medium sell? How many times did large sell? That's a frequency distribution. So small, 39 number of times sold. Large, 55 number of times sold. Like that. That's the frequency. Frequency is a count, right? Basic elementary physics class. So that's how you make frequency distribution tables of categorical variables. Now in Excel, you have pivot tables to do this job, and relative frequency is often calculated. Relative frequency is basically a comparison, right? You basically take these numbers and convert them to percentages. That's what relative frequency is all about. And yeah, there's another function called unique, which can help us figure out what are these categories in the categorical variable. Similarly, there is numerical frequency distributions, which I just showed you the example in the pizza example, which had we had bins for the pizza sales, right? Because it does not make sense to have like, hey, number of pizzas sold 13 today, 14. So the bins will be very small. So it's better to have some kind of aggregation and make those bins bigger. That's the idea behind that. Then we have histograms. Histogram is basically this visual only out here that tells you how things went, right? Now, just to make this concept a bit clear, if you look at this is a histogram in its own right. That's what I've coded it differently, a bit dark. Monday has occurred 48 number of times. That is a frequency distribution table for this variable, the weekday variable, right? Out here, Monday occurs 48 times, Tuesday 52 times. So this way we know how much data we have for how many times it occurred in the whole data set. And similarly, we can represent this histogram like a frequency distribution table where each bin would be a row and the numbers here would be their consecutive, yeah, would be the respective values for the frequency. Like 89 has occurred for this bin, 125 to 137. I hope that's fair, right? So that's the idea of distributions. I don't think this needs much explanation. It's about which category and how many times it occurs. That's what frequency distribution is all about. And histograms are basically a visual representation of frequency distribution tables. That's about it. Now I would like to move on to central tendencies. Central tendency we all know, right? Mean, median, mode. Now, means is the arithmetic average. So you take the sum of all the values of a variable and then you divide it by the number of times they occurred. That's a mean. So in Excel, you have this formula called average. You use that, or you even have you can use average if you want to, have for a specific category in that day. For example, I want to count the number of times Monday occurred. So like or when the average number of sales only for Mondays. That's where we'll use something like an average ifs. Moving on, averages then median is the middle value of a number of a variable. So let's say I have 500 people standing in a queue, right? And they're standing height wise. So it's the person in the middle. So 250th person basically is the that guy. Not even the two. It's the average height of 249th person and the 250th person. Basically, the number of people you have, you make them people or a variable, you have them in an ascending order and then you pick the middle one. And if there's an even number of rows in that particular data set, then you take the average of the middle two. That's the idea here. Okay, so that's about median. And finally, mode is the most number of times a particular category occurred, right? So, like if in the same data set, like there are 500 people standing, if people with the height of 5 feet and 8 inches happen to be 255 times. So that's like the majority of the times you see that particular height, then that's the mode, right? Mode is the most frequently occurring number, not a number, the category or the numerical value. Hope you get the idea there. Now, skew is not a central tendency in itself, but it tells us how the data is, structured. So a right skew tells us that most of the numbers are towards the right. Like there are outliers basically. It's not a normal distribution like this. Okay, so out here in our example, we can see that it's a right skewed distribution because there are more numbers towards here and it's not, structured evenly to the mode. Like 89, this is the mode, right? 125 to 137 category, that's the mode. So if things had been structured equally to its left and to its right, which is called a normal distribution, then it would be not have skewed. It would have zero skew. But in this case, it's a right skew. Okay. So that's about it. And what else? So yeah, when we have a right skew, generally the mean is greater than the median. When we have a left skew, the mean is smaller than the median. That happens because the outliers they influence the mean more than they do the median. So an example of this would be a cricket match. Let's say a person scores a double century and everyone else only scores 20 runs. So the average score would be more than 60, right? But the median would only be 20. Right? I hope that makes sense. Just think about it. Like if you sum up all the scores and you divide it by the number of people there, and if there's one outlier, which is the person who scored the double century in the example I gave you, then that skews the result towards the right. Right. So that's the concept of skew, right? And there's a function called skew in Excel, so that helps. Then variability, it's a concept of the spread, right? Like, okay, the whole concept of central tendencies is to pick the number in the middle, right? Like the best possible guess. So if we have outliers in our data, then the best possible guess is the median, because most probably it the mean has skewed it, right? I mean, the mean is skewed because of the outliers, which is bad for us, and we want the median because it's a better representative of the center. So that's the whole idea there. And what else? So, and even there's a concept of outliers, right? So outlier is something like what I was saying, right? What is an outlier? It's something that's influencing the mean to go towards the right or towards the left. Similarly, an outlier from a mathematical perspective, it's basically the formula we use for that is Q1 minus 1.5 into IQR. IQR is the interquartile range, and that is what we are coming to right now. So quartiles is basically very similar to the concept of median. It's derived from there. So it's like let's say take the starting point and I take the median, right? Now, I just consider that and I take the median of that part. Did you get that? There's a whole data set, point A, point B. We go for the median. That's the number in the center, right? Like, let's say 500 people in an ascending order of heights. The 249th person and the 50th person, the average height, that's the median of that data set. Now I pick this person and the first person here and the 249th person here, and I look for the person in the center there, right? That's the median of the next data of the median's median. That essentially is the first quartile. Similarly, the third quartile is take the second quartile, which is the median, and take the maximum value, like the last person in the data set, and take the median of that. That happens to be the third quartile. So if I have to give you an example, it's like on Monday, the first quartile is this one, 143. No, this is the third quartile, and the first quartile is 125.25. So that's how it's done. And we basically, this is called the five number statistic, right? The minimum, the first quartile, the median, the third quartile, and the maximum. This is called a five number statistic that tells us the spread of the data in a holistic way. Hmm. So yeah, I don't know how clearly I was able to explain this part, but yeah, I hope I was able to make sense. In terms of variability, the measures we are having is the range, simply maximum minus the minimum. Then there's what else is there? There's the standard deviation also. Variance and standard deviation, they're like very similar concepts. Variance, yeah, standard deviation is like the average distance from the mean that the average data point is having, right? So on an average, how far away is the data point from the mean? That's what a standard deviation measures for us. Hmm. And the calculation is fairly simple, right? It's just the square root of variance, which is basically the observation. It's the sum observation minus the mean divided by the number of observations that are there. You whole square it and then the square root. I mean, you can look these things up. They are very simple to understand. I just wanted to provide these resources to you guys because I think this kind of comes handy, right? The concepts themselves. So the idea for making this video was to provide you with this notes, right? It's pretty handy to have something like this where you can just scroll up and down and check things out. This, and I'll give the Excel as well because I think it's a good way to demonstrate the concepts. What's a box and whisker plot? What's a histogram? So yeah, that's pretty much it that I wanted to talk about today. Thanks.